Sorry about that. I got cut off in the middle of number 29. Okay. Now, what I was just describing is actually probably the most important part. So I'm just going to kind of start over a little bit and re-describe what was going on. These are coefficients. Coefficients are whole numbers out in front of variables. Only out in front of variables. So we have -3, +6. That's a constant. It's not a coefficient if it doesn't have a variable. Now, technically, there's a really, really good school of thought that I actually kind of agree with that says that would be -4x to the 0 power, which makes a constant a coefficient. I'm on board with that, actually. But as far as the state of Georgia tends to carry it whenever it's on the EOC, they just worry about coefficients being numbers in front of variables. And you'll see I wrote a comma, but I didn't ever fill it in. That's because I haven't gotten to the last one yet. That's a variable x, and there is a number out front of it, a -1. These are our coefficients. Nothing more, nothing less. That is where D will get people in trouble. They'll think, oh yeah, that's one of my pieces. It's not asking for a term. If it asked for a term, D would be correct. That's the whole term, but it wants coefficients. The only one of my coefficients that shows up is option C. Okay, option C is the only coefficient that shows up on our list. The other ones are just there to trick you. -4, well, if you pick the constant, you get it wrong. 5, if you were looking for exponents, you get that one wrong. Okay? Number 30, factor completely. This is where you had to know that little trick about difference of perfect squares. And on top of that, you had to remember, the golden granddaddy rule of all factoring problems is to GCF first. I can take a 2 out of all of these. I can't take any variables out because they're different variables. I get 9x squared minus 25y squared, and those are both perfect squares. 9 is 3 times 3. 25 is 5 times 5, and this is a difference. We learned these are called difference of perfect squares, and to do those, we can go straight to the answer. We take the square root of the first term, which is 3x, and then add it to the square root of the second term, which is 5y. And then we do the same thing, but we change the sign in the middle. We evaluate to make sure we have factored completely. No way to get anything out of 3x plus 5y. No way to get anything out of 3x minus 5y. That's our answer. All that goes out the door with this second one because we've got 81 a to the 4th power minus 1. Well, you sit there and look and go, wow, there's nothing I can get out of those. What? There's no GCF. I must not be able to do this problem. It'd be really good for one of our distractors to probably say unfactorable, okay? Because it'd get a lot of people. You'd think, oh, there's nothing I can get out of there. But 81 a to the 4th is a perfect square. 9 times 9 is 81. 1 is always a perfect square or a perfect cube or a perfect 4th root. It's just however many ones you need it to be. So if I'm going to factor this, I take the square root of the left side, which is 9a squared, plus the square root of the right side, which is 1. Square root of the left side, 9a squared, minus the square root of the right side. And this is where a lot of people get this problem wrong as they go down here and they circle A. And that, honestly, to me, guys, is really good work. This problem is tricky. It says factor completely. Now, the first binomial, 9a squared plus 1, there's nothing I can do there because it's a plus sign. This has to be a difference. Difference meaning subtraction of perfect squares. And the right binomial is still a difference of perfect squares. My first binomial pops down, 9a squared plus 1. We couldn't do anything with it. My second binomial, I can take the square root of the first piece, which is 3a, and add it to 1, and 3a, and subtract it from 1. This would be factored completely. Not just partially, completely, giving us option C. Okay, option C. Very careful there. That's very tricky. Number 32, simplify. Guys, it's an easy problem. Don't make it harder than it has to be. I've had a lot of people today that are going to me like, oh, Mr. I know how to do this one. We're just going to multiply and multiply and multiply and multiply. And whoa, 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 whoa. Whatever told you to multiply? The only thing that would have ever told you to multiply would be the symbol in the middle, and that's a subtraction sign. So we're going to subtract these two things, which is just a big old complicated version of combining like terms. If you like to distribute the negative sign, you can do that. That's going to become a negative x squared, a positive 3x, and a minus 1. And now we're going to combine our like terms from up here and down here. And that's going to give us the same answer that if you do it without that step. Without that step, it just requires a little more mental gymnastics. 7x minus x squared. Well, that's a 1x squared, so 7x squared minus 1x squared is 6x squared. Negative 2x minus negative 3x. Be very careful. That's a lot of negatives flying around. I've seen a lot of people give me this answer today because of this. But negative 2 minus negative 3, that's plus positive, meaning we get a positive 1x. You're never going to see that 1 actually written there. It's just going to be written as a plus x. Finally, negative 3 minus a negative 1. Well, negative 3 minus 1, minus a positive 1. That's going to be minus 4. So, mental gymnastics over. Answer is D. Very careful. Again, if you just distribute the negative, you can combine the like terms the same way like it's an addition problem. Number 3 is tricky, and the distractors are really good on it, okay? The distractors worked out really nicely. First off, we have to simplify this. I'm probably going to need a little bit more room, so I'm going to hop over to another page. We've got 2 on the square root of 252, x fourth, y to the 5th. Well, I can break down the number. I've been practicing that a lot lately because we've been doing so much quadratic formula. I'm a lazy man. I don't look for big numbers. I just look for the fact that it's even, or is a 3, or is a 5 going to go into it. Simple prime numbers, sometimes a 7. Well, whenever I break that number down, it's 2 and 126. How do I know that? You throw it in the calculator. You do 252 divided by 2. It's going to be 126. 126 is even, so I can divide that by 2. I get 63. Now, 63 is not even, but I can break it down with a 3. Me personally, I look at 63 and say it's 7 times 9, which makes this a little bit quicker, but breaking it down with 3 and 21 is equally useful. Okay? Pair of 2s is going to come out. Pair of 3s is going to come out. The leaf that we left behind is 7. Well, that's going to be, when they come out front, they slam into whatever else was already out there. So we've got 2 times 2 times 3 because that 2 was already out there. This 2, I'm going to rewrite it in black because it was the original one, was already out there. Okay? Next, what's left inside the radical is our leaf of 7, x fourth, y to the 5th. We're not done yet. We've got to deal with the variables. Just like with numbers, the variables can come out in pairs. That's x times x times x times x, because we have 4 of them. Y times y times y times y times y. Well, there's a pair of x's, and there's a pair of x's. They all came out. There's a pair of y's, there's a pair of y's. They all came out. We left 1 y behind. They didn't all come out. 2 pairs came out. We left 1 y behind as our little leaf. Now we got to clean all this up. 2 times 2 is 4, times 3 is 12. X and x came out to be x squared. Pair of x's comes out as a single x. Pair of x's comes out as a single x. 2 single x's is x squared. Okay? Y times y, or y's come out in pairs as well. Okay? To be a y squared. What we left behind is the 7 and the y. That gives us our final answer of C. Guys, take a look at some of these distractors. If you didn't know that when the variables come out, they also get square rooted, you'd end up circling D, and it's wrong. Okay? Look at those. Those are really close. Everything else is the same. Look at option A. What do you think happened in option A? That's a really easy to get that one. You think, oh, well, no, it's just the wrong number out front. No, it's a very, very particular wrong number out front. If you forget about this starting 2, whenever you simplify 252, you'll have a 6 pop out front. You're supposed to have a 12 because that 2 was already there. Very, very good distractors on that. Be very careful.